Good evening, good afternoon, and good morning from wherever you're joining us from today. My name's Sarah, and I'm the Program and Event Manager at the Reactor in Sydney, Australia. Welcome to another Microsoft Reactor Sydney live stream and event, and another episode of our Devs Down Under series. Today, I would like to welcome back Deepak and our new guest, Nirmal. Hi, guys. Tonight, they will talk through Azure Route Server. However, before we begin, I'll just give you a little bit of background. So Deepak is a Microsoft Azure MVP, currently working as an Azure capability lead with Insight Enterprises in Perth. He's been working on Azure for a long time, and he also shares his learning and experiences on his blog, which we can share later on. Nirmal works for Microsoft as an Advanced Networking Global Blackbelt, looking after customers across Asia, Australia, and New Zealand. Before this role, he worked as a cloud solution architect, helping customers migrate their own premises workloads to Azure, and worked on large-scale remote work initiatives enabling organizations to operate during the pandemic. You will see I've added into the comment section there a link with the event check-in and the event code. The event code for today is 14240. So if you could enter into that code into the link, you'll be able to get a whole bunch of additional resources from today's session. We'll also put in at the end a link to the feedback survey. So if you could also put in the same event code, that would be great. And this one will go straight to our YouTube live channel after this. So there will be the on-demand version available straight after on our YouTube channel. So we've also shared with you all of those links in the check-in link. But for now, without further ado, I'd like to hand the floor over to Deepak and Nirmal to begin. So thank you both, and over to you.
Cool. Thanks, Sarah, and welcome everyone. Thanks for joining session on the Azure Route Server, where we're going to talk about dynamic routing using Azure Route Server. So my name is Deepak, and I'll kind of kickstart the session. I'll talk about Azure Networking, why we use Azure Route Server, and one of the use cases of Route Server. And then Nirmal will take over, and he will talk about the second use case of Azure Route Server, where he will show how can you use Azure Route Server to propagate the BGP routes to the VMs which are running in Azure Virtual Network, and we'll talk about the SD-WAN failover scenario and some Q&A in the end. So this is a kind of a demo-heavy session. Feel free to ask your questions during the sessions, or feel free to post it in the chat window. Now, when we talk about the Azure Network topology, and when we talk about the cloud adoption framework, so there are two patterns which are outlined under the cloud adoption framework landing zone, patterns. The one is the managed network, which is kind of like purchasing a house which is already built for you, and you do not have much to modify in it because the house is built, everything is set, and this is like a Microsoft managed one, which is Azure Virtual vWAN. Now the second option is kind of traditional, which is hub and spoke, which also called as do it yourself, where a customer can choose what kind of devices they want to put in their VNet, you manage your VNet, what kind of gateway you want to put in. So it is more control in do it yourself versus the managed network. So these are the two different patterns, and we're going to talk about do it yourself hub and spoke model. Now, hub and spoke model is good for customers who want to have more control over their network. They want to decide which network virtual appliance they want to deploy, whether it be Palo Alto, FortiGate, Firewall, Cisco, CSR, and things like that. And they're also looking for like low number of branches, like under 30, not like huge number of branches, where you would prefer to go for the managed one, which is the Azure Virtual WAN. So before I talk about Azure Route Server, it's quite important to understand the Azure network routing. So it's kind of a 101 for Azure network. So when it comes to deploying a VNet, so what a virtual network does, it is kind of a representation of your network in Azure. It provides a dedicated, private cloud-only connectivity to the network. It also helps you extend your network to on-premises, which means you can actually connect your network and connect your on-premises devices as well. So this is the first thing which everybody has to do when they want to deploy any workloads in Azure. They need to create a virtual network. Now, once the virtual network is created, what happens is there are number of routes which gets created. Now we are talking about the system routes, which are the default routes, in Azure. So any traffic within a virtual network, it is kind of unrestricted, means a VM sitting in one subnet of virtual network to a VM sitting in another subnet of virtual network can talk to each other. Any traffic which needs to go to internet, any traffic which needs to go to on-premises using site-to-site VPN or express route, that is all governed using the system routes. They're also called as default routes or system route. So this is the default way. Now, second option is user-defined route, and they're also called as custom routes. Now, when these system routes are created, now there are users who need to manipulate or change these routes. So for example, if you deploy a firewall, you would not want a traffic to go to internet directly. You would want traffic to route through the firewall where you can have some sort of inspections, you can have some sort of restrictions, and you may want to define which traffic is allowed, which traffic is disallowed. And that is where the custom route comes in, because they allow you to manipulate the default route and override them with the route you want to implement in Azure. So how you implement the custom route? So you implement the custom route by creating the user-defined route by deploying a route table. So you provide the name of the route, you define to which address this route table should be applied, and which is the next hop. So virtual appliance means you want to send all the traffic to a firewall and let firewall decide whether the traffic is allowed or disallowed. And obviously you configure firewall to allow or disallow the traffic. So that's how you create a custom route. Now, from a VM perspective, so when we deploy a virtual machine in Azure, it shows what kind of route it is receiving, because a VM should know which network it can go and what is the next hop, by using which hop it can go and connect to another network. So if you look at in the top, we've got the default routes, and those default routes are created where you create a virtual network. So the next hop type, if we look at it here, it shows for the first route, it is virtual network, which means all these routes for this IP address are part of the same virtual network. Whereas this virtual network is also paired with another virtual network. So peering is a way we can connect multiple networks together in Azure. It shows it is VNet peering. So it is using VNet peering, and with that, my VM in this virtual network can communicate to the IP address range 192.168.1.0. Now, apart from this, there are a whole bunch of routes which we are receiving. Those are virtual network gateway route. Now, these are the routes which are received using the BGP. So this machine is connected to a BGP-enabled site-to-site VPN, and all these routes are actually received from the gateway. So by default, Azure Virtual Network Gateway also acts as a BGP device, and it injects these routes to all the VMs or all the VMs in a virtual network connected to the gateway. Now, in this hub and spoke model, I'm getting and receiving these routes from my gateway, where it is telling me to go to these address prefixes. I need to go to the next hop, which is my virtual network gateway. That needs to be, there. Now, there is another route in the bottom, which is the user-defined route. So this is what I have, created by using a route table. Now, what this route is dictating, it is saying 0.0.0.0/0. It is kind of a, anything which is unknown. So if there is no known routes, it could be internet or it could be any route which are not mentioned in this table, then the traffic should be thrown to a virtual network appliance. So we have, NVA and the IP of the NVA is 192.168.1.5. So this is how the routes gets manipulated, and every virtual machine knows to if it needs to go to a certain traffic, where it should be going. Now, if you look at it here, by default, Azure provides some connectivity to the internet, which is a default route. Since I have used the user-defined route or custom route, it has overridden this route and made it as invalid, because at any given point of time, only one route should be active. And if it is a same IP address space, another route needs to be deactivated. So that's where it became invalid. And the way the routing works is we have got some sort of priority. And the way priority works is the lowest priority goes to system route, because these are the default route. You can't manipulate them. They get populated or injected in the VNet the way it is configured, like with the VNet peering, with the gateways and things like that. And then second, we have got the BGP routes. So BGP routes, what it does, it basically populates the route from the on-premises device, and you get to know what's the on-premises IP addresses, especially in the case of site-to-site VPN or a express route scenario. Now, any of these routes, they can be overridden by using the user-defined route. So that's how the priority works. The system route and then BGP route. So obviously, BGP routes can override the system routes, and user-defined routes can override BGP routes and the system routes. Now let's talk about Azure Route Server. So what is Azure Route Server? So Azure Route Server provides the BGP endpoint for virtual network appliance to connect. Now, so we have seen in the case of a virtual network, and in a scenario, if it is a large organization, we would need to create those route tables. So if I deploy a firewall in virtual network in Azure, what I'll have to do is I will have to create route tables, and I'll have to attach that route table to each and every subnet in my VNet to say to go to internet, to go to a different network, you need to go through the firewall. Now that's something which I'll have to do manually or using the script, but I'll have to manage and maintain that list. And at the same time, if I add another subscription and if I add another virtual network, I'll have to configure the route table for that virtual network as well. Now, in that case, what the route server does, it just provides the BGP endpoints, and it also allows first my virtual networks to communicate to the route server and propagate these routes, like what is the virtual appliance IP address, directly injected to the VNet. Now, all my virtual network, without the need of route table, can have the IP address of my network virtual appliance, the firewall. So it helps you simplify the network virtual appliance deployment, and it also helps in a scenario where it provides the connectivity between branch to branch. Now, in the case, if you have got multiple branches connected to Azure, so let's say you've got a primary office which is connected to the express route, and you've got secondary locations connected to site-to-site VPN. Now, with the help of Route Server can inject the route from express route to site-to-site VPN and site-to-site VPN to express route. So it helps exchange the route, and it allows the branch-to-branch connectivity. Now, Azure Route Server is a fully managed service. So it's just like a platform as a service, which you can deploy in Azure. And when you deploy the service in Azure, there are two instances of Route Server which gets deployed. Now, Azure Route Server doesn't come between the data path. Means if a VM has to talk to firewall or VPN gateway or express route gateway, that traffic goes directly. The route server only provides these routing information. So it doesn't come in the data path. It only provides the routing information to the virtual network, as well as the VMs sitting in the virtual network. Now, for the high availability, there should be at least 2 NVA that needs to be deployed. And Azure Route Server provides 2 different patterns for NVA. One is the active-active, and second is the active-passive. So the active passive scenario works with the AS path prepending, where one route becomes the active one and the second route becomes the passive one. If the active one is inaccessible, the second route is kind of used, which means you only have one firewall working at a given point of time. And the second deployment pattern is the ECMP, which is the equal cost multipathing. And in that case, equal cost multipathing, you have both NVAs, and a VM gets the information of both the NVAs, which means it can route the traffic using NVA1, and it can also route the traffic using NVA2. So it just allows two NVAs to come and work together. So these are the two different patterns which can be used with the Azure Route Server when it comes to connecting to the NVAs. Now, there are some specific requirements when it comes to using the Azure Route Server. You cannot use the ASN number 65515, which is basically reserved for the route server. And you also need a subnet, a /27 subnet, in order to create a route server. So if you're deploying a route server, you need a /27 subnet, and there shouldn't be any other service running in this subnet, and the subnet name should be route server subnet. That's kind of a requirement for Azure Route Server. Now with this, I'll quickly jump on to a demo where I'll show you how do we kind of, provision the route server. So this is my lab environment, and I have got, route server. So what I've done is I have just clicked on this URL because route server is in preview, and you need to, connect to the URL, which is aka.ms/route server, and then only you would be able to configure the route server. Now, once you come and access the Azure Route Server, you have the option to create a new route server. And you need to select your resource group and obviously your subscription. And you need to give it a name. A reason where it needs to be deployed. And the virtual network. And you could say it has picked up the route server subnet automatically. Now, there are other subnets within the virtual network, but since it just uses the route server subnet name, it has picked up that subnet. And then once we click on create, it will create a route server. So route server also requires a public IP address. We can provide the name of the public IP address, and then obviously we can click on review and create. So once this information is kind of accepted, validation is passed, I click on create, and it's going to take like 30 to 40 minutes to deploy a route server. Now, since the route server is already deployed, because just to save a time, don't want to see you guys how the route server is getting created. It takes its own time. Once it gets created, you would be able to see the route server which is available. So in this case, I gave a route server name as the route server. And once I select this route server, I can configure peering, which basically allows my NVS to talk to my route server. So the way we create peering, we click on add, and we give it a name. For example, it's NVA1. Give it the the ASN number of my NVA, which is firewall, as well as the IP address of my NVA. So I would need to provide this information so my NVA can communicate to the route server. So if I've got multiple NVAs, I will add those details, and I would be able to click on add. Now, apart from this, if I want to enable branch-to-branch connectivity, I'll have to come on configuration, and I will have to enable this checkbox, which is like enabled. When I say enable, it will allow my branch network, which is connecting to my Azure using site-to-site VPN, to connect to my office network, which is also connected to my VNet using the express route. So it will allow me to basically inject my branch network route to the office route and office routes to the branch network VPN. And I'll show you in a minute about how do we enable and what difference does it make. So if we come on overview, here we can see that the ASN, which is used by this route server, is 65515. And that is the reason we cannot use this ASN with our VPN as well as the express route as well as the network virtual appliance. We'll have to use different ASN number because it is reserved and used by the route server. Now, it also gets deployed and highly available. So if you look at it, there are 2 instances of route server, and they have picked up 2 different IP addresses. So this is all managed. I can't, RDP or SSH to the route server and manage it. It's a fully managed service. Now, if the route server is deployed in a region which supports the availability zone, now what will happen? One instance will get deployed in one availability zone, and the second instance gets deployed in the second availability zone. So that's how it provides the high availability in the route server provides the high availability. Now, so one thing I have done in my network, I just need to make sure my network also has got the. So in the case when we are using the so I've got my hub network, I've got my spoke network. So if I select my spoke virtual network, and if I look at my peering, so I need to make sure that I have got this checkbox selected. So all my peered VNet, they should have this checkbox selected, use the remote virtual network gateway or route server. So this is kind of a typical hub and spoke model. And if I don't use it, I would not be able to take the advantage of the Azure route server. So this needs to be selected for my peered network. So in an ideal scenario, if you're using express route or site-to-site VPN, it is selected. Very recently, you would see this route server name is also added. It used to be only the remote virtual network gateway. Cool. Now, I'm going to talk about the route server use cases. Now, so as we talked about, we're going to talk about different use cases of route server. Now, in this scenario, we have got a virtual network in Azure, and that virtual network is basically connected to on-premises using the express route, as well as it is also connected to different branches using the site-to-site VPN. Now, what route server is doing, it is basically exchanging the routes between the express route and the site-to-site VPN, and it is allowing the VMs sitting in my on-premises branch 1 to connect to on-premises 2 with the help of Azure. Now, just to kind of show you how it works to kind of demonstrate my demo. So I've got a kind of reference architecture which I've created. Now, in my scenario, I have got my VPN gateway, I have got my ER gateway. So ER is connected to one of the remote branch, and my VPN gateway is connected to 2 of my branches. So this is the IP address range, and I've got a VM sitting in Azure as like my spoke virtual network. So my VM sitting here should be able to communicate to all these locations, as well as it should be able to ping my on-premises location as well as my branch location. So just to kind of demonstrate, I will just go back to my demo. So what I'm trying to do here is from this location, because I am connected to one of my branch, and I want to ping and connect to my connect to an IP address, which is basically sitting it here, right? It's 10.150.0.2. So ideally, I should not be able to communicate because the VM is sitting behind this location, and I should not be able to connect to this branch. So what I'll do is I'll first try to ping, and then I'll enable the communication. Okay, give me a second. I'll go back and enable the route server. So while it is creating, I will connect to a VM, which is sitting behind the. So this is my VPN. This is the VM which is sitting behind my VPN. So I will quickly jump here. Yep. So it is pinging because what's happening is I am connecting from my branch. So one of the VM from my branch is able to connect to my VM sitting behind the express route, which is in the main office. So if I just go back, and I could see it is updating. So this is kind of takes almost a couple of minutes in order to update and propagate the routes. Now once these routes are propagated, what I also see is if I go on my VM and if I go and look at the effective routes. So the way we look at the effective routes, so this is the way we look at the routing and what route information a VM is receiving. We select a virtual machine, select the networking, select the interface, and within that interface, I look at the effective routes, and this shows what routes my VM is receiving. Yep. So my VM sitting in Azure, it is able to receive all the routes which are coming from my site-to-site VPN, and it also has got the routes which are coming from my my express route location as well, which is this route. And once it is done, I can even connect to one of my router, and so I could see I'm receiving the BGP route, which are coming from my express route. So this is my VPN router, and it is able to receive the route coming from my express route as well. So that's the route I'm receiving. So this kind of a scenario, which basically kind of shows how do we connect branch to branch using the Azure Route Server. All right. So yeah, that's what I wanted to show. Now I will hand it over to Nirmal, who will be talking about different use cases. The second use case, which is NVA integration to the route server. Over to you, Nirmal.
Perfect. All right. Thank you, Deepak, for the great introduction you did for Route Server, and also walking us through sort of the platform behavior on Azure as to how we prioritize routes, and also the effect and the behavior of user-defined routing. So if I do a very quick recap, Deepak talked about a use case where a customer would want to use ExpressRoute and VPN to do a transit. So that's the first use case we had a look. What I'm going to cover in my demo and in my use case is that we are going to look at if a customer wants to implement network virtual appliances, whether it's for traffic routing or whether it's for firewall functionality. We are going to look at how Route Server can help. So if I really look at why we would need Route Server, what is the benefit of using Route Server? Traditionally, if you don't have Route Server, what you would be doing is you would be creating user-defined routes per subnet, and you would then be creating statically defined routing to say, whenever traffic needs to go to the internet, this is going to be my next hop. Whenever traffic needs to go back to on-premises, use my NVA as the next hop. So in a small scale environment with fewer VNets, it's easy to manage. But as you grow your cloud environment, as you add more and more VNets, it becomes harder to go manage your user-defined routing, because especially for traffic that needs to go back to on-premises through a firewall, you need to manually add those routes to the gateway user-defined route to say, if my destination is this VNet, pass that on through the firewall. So with Azure Route Server, we don't need to utilize user-defined routing. Instead, what we do is we allow the route server to learn routing from the NVAs or the network virtual appliances, and then inject those routes back to the Azure platform. The other key thing to note here is that even though the Azure Route Server is learning these routes and propagating to the platform, it's actually not in the data path. So whenever traffic is flowing, traffic is not going to go through Azure Route Server. So it's only acting as a BGP speaker for learning the routes and then advertising it back to the platform. So today in my demonstration, I'm going to walk you through two different use cases and two different scenarios. So the first scenario we will look at is if you are placing an NVA and if you are using an active-passive topology or the architecture, how can Route Server help? And then I'm also going to talk about if you do deploy your network virtual appliance in an active-active architecture, how can the Route Server help? So with that, let's go into a demo. So let me minimize this and go to my Azure portal. and I'll explain the demo environment that I have. So what I have done is I've built a simplified hub-spoke topology. So here, if you look at, this is my hub VNet, and then I have two spoke VNets part of this hub-spoke topology. So these two VNets are paired to the hub, and then the VNet is also going to use the gateway that's deployed to the hub VNet. So if this hub is connected back to on-premises, traffic would go to the hub VNet, and from the hub VNet, it'll use whichever the connectivity method that I have from the hub to get back to on-premises. What I also have is a new component here, which is the Azure Route Server component, which, as Deepak explained, needs to be deployed on its own subnet, and then you build the route server resource. So once the route server resource is built, it's a fully managed resource, and then you configure the peering relationship. So these are the two VNet VMs that I have. So these two VMs, in my example, I'm using a Cisco CSR 1000V VM. These two VMs are then paired to my route server instance. The same architecture and the same topology, I've also got it running in my second lab environment. But the difference here is, rather than doing an active-passive peering, I'm actually doing active peering. So when I go to my effective routing, I'll show the difference when you do active-passive versus active. But before I go there, let me open up my Azure Route Server, and then let me show the configuration that I have done. All of the configuration that I'm showing here, we can utilize the Azure portal to do it. We could utilize CLI, PowerShell, or the REST API to do this configuration. So if I go to my peering relationships, what you would notice is that I have a CSR1 VM with AS65001, and then I have the IP address. So this is my first VM. And then here I have my second VM using the same AS. And then I have the IP address that's part of that particular appliance. So I have two NVAs, or two appliances, paired to my route server. And this environment is configured as active passive. So what I'm going to do now is I'm going to go to one of these VMs. I'm actually going to pick Spoke 1. And then I'm going to pick one of these VMs to go in and have a look at the route table to understand the behavior once route server is integrated to your environment. What does it really look like from an effective route perspective? So let me open it up. While that's coming up, another advantage of route server is it's much easier to go in and implement route server because it's a managed appliance, and all you need is a subnet that you can allocate in your hub VNet. So as long as you have sufficient IPs, you can simply go in and turn it on. Recommendation and the suggestion from us is to do it under change management. So you will have a downtime window that you organize, and then you will go implement route server in the current topology. So you don't have to go in and rebuild your landing zone or rebuild the environment. It's a easier approach to go add this capability if you would want to take advantage of these capabilities. So here, this is my effective routes, the route table of this particular VM. So a couple of things here. The first thing is that I have few routes that I'm advertising, and the one that I'm specifically going to look at is the routes that I have learned for my internet path. So 0/0 is my internet path, and the internet path, I'm actually learning that from 2.11. So here, as Deepak mentioned at the start, we are only seeing one route, even though I'm advertising two routes, both from my 2.11 NVA and also from my passive NVA. So to do this, to make it active passive, I'm using a concept called ACE path prepend, which means that I'm using my BGP attributes to go in and influence to say this is my active path and the other network path is my standby path. So the standby path is not going to be visible here, but I'll show in the demonstration when we go in and when we do a failover, we will then be able to automatically see the failover path being injected to our platform routes, and the VM would be able to use that path to go out to the internet. So that's the configuration that the spoke VNets would be receiving. So whenever I advertise a new route, it will automatically be part of platform routes, and the VM would learn that using Azure Route Server. So other thing that I want to show is I want to log into one of these VMs. So let me do that. Let me find my active passive VM and log into it. So this is my active passive VM. So I've labeled this terminal because I've got another terminal with the active setup. So a couple of things I want to check. So I've already logged into this VM. Let's just verify the IP address. Yep, so it's 10.1, 3.4. So that's the first VM in my network. So now I want to see which path am I taking when I go to the internet. So if I do, I want to look at the trace route, and I'm going to say, show me the trace route if I'm going to Microsoft.com. So here you could see that the next hop path is 2.11, which is the path that I've set for this to go out to the internet. So if I close this and if I do a test on this website, I would get response 200, which means that yes, we can go in and hit this web page. I'm getting a HTTP 200 response back as a success. So what I'm going to do now is I'm going to do a continuous ping. So again, you're going to select a different website. So I'm going to do bing.com, and then I'm going to let this go. So here, what we are doing is I'm doing a continuous ping. And while this is running, what I'm going to do is I'm going to run a script to do a forcefully disable the network interface of my CSR device. So let me open up Visual Studio Code, and what we will do is we will, while this is going, we are going to run the interface shutdown command. So let me do that. While I do that, I'll also get the window here. Let me minimize it. Yep. So just going to bring down interface. So you will see here what I'm doing. Let me maximize it. So here what I'm doing is I'm running a command to say, go to CSR and disable my Ethernet interface 2. So it's now shutting down this interface. And then the response that I'm expecting to see here, you can see the ping request has already hit post. So packets are not flowing before, so it is now. But what you just experienced is that we've now switched over from the active instance to the passive instance, because the passive instance took over given we've already shut down the active instance and traffic is flowing through. So it took around 40 seconds for this operation to take place. So we're switching from one to the other. But you didn't have to go do anything manually. It's an automated switch because BGP learned that there's a failure in this interface. I can't talk to this interface anymore. Now I'm going to use my BGP ACE path preference to understand what is the next available path, and then I'm making the second path active. So if I now switch back to my Azure portal, and then if I go to effective routes, what we expect to see here is that instead of .11 IP, we should be now seeing the 12 IP, because that's the path that I'm now taking to go out to the internet. So here you can see instead of 2.11, we now have the 2.12 IP. So it's automatically gone in and changed the routing in the platform without me needing to go in and do anything manually. So that's the active passive scenario, and that's the active passive, the passive VM taking over. So if I close this and do another MTR, you would notice that this is going to go through 2.12 instead of going through 2.11. So with that, I'm going to switch over to the second scenario where I'm going to be using an active-active setup because active-passive might not be a use case for you. You might want to take advantage of resources that you're already using. So because the standby VM is already there, you might want to run them as an active-active pair. So let's have a look at what is the behavior for active-active. So to do that, I'm going to do a couple of things. The first thing is I'm going to go back to my Azure dashboard, and then we are now going to focus on the active-active lab environment. So a couple of things to note here. Again, I'm going to go to Route Server, going to go to peers, and show you it's exactly the same setup. But the difference here is that instead of using ACE path prepend, I'm essentially advertising the same path into both the CSR1 and CSR2. They're all advertising the same network path to the platform. So if I go back to my dashboard and if I look at one of my spoke VMs, what we expect to see here is that because I'm advertising both path to the platform with the same, essentially the same network path, I'm expecting to see both the addresses listed here. So we'll see here the difference. Because there's no ACE path prepending anymore, the path that I'm using for the internet path, which is 0/0, I'm now having two network paths. So essentially, I can load balance between these two paths. When we log into the VM, we will notice some traffic will go from one NVA and some traffic would be leaving from the other NVA. So with that, let me log into the active instance, and then we will try a couple of websites. So this is my active instance, again, the same setup. So here what I will do, I'm going to do, again, do a trace route, and let's do ping.com. So that's going through 2.11. Let's try a few other ones. Let's try, Microsoft.com. So that's going to go through 2.12. So as you can see, it is load balancing this request based on the request that's coming in. So one will go via one NVA, the other request would go via the second NVA. So here what I want to do is I'm going to do the exact same thing we did before. I'm going to go in and turn off the interface, and then we will see how traffic gets redirected to 2.12 because 2.11 would be unavailable, and we will also see how that gets removed from the platform. So for that to work, I'm just going to double check if that's going to go with that's 2.12 now. So let me try this one to see if it's going to go through 2.12. Let me try another site. Let's say abc.com. That's also going to go through 2.12. Let's try google.com. Yep, so that's going to go through 2.11. Let me just double check. Yep, 2.11. So I'm just going to do a ping against google.com. And yep, so we have the ping flow happening. So this is now going through 2.11. And now what I'm going to do is very similar to what I did with the other environment. I'm just going to go and execute a command to bring down the interface. So let me open up my VS Code, and I'm going to switch to my active script, and then switch my terminal. And here I'm going to now bring down the CSR interface. So to do that, I will also have this running here. Let me bring it in, and let's just run this one here. So here, what I'm doing now is exactly the same thing. It's talking to a different CSR, and it's going to bring this interface down. So when we bring the interface down again, exactly same as before, we will see there's going to be a slight disruption. And then when we fail over to the second interface, you will see that the traffic will continue to flow. So you don't have to, again, go do any manual changes. Platform will do the change automatically. So it takes about 30 seconds. So let's see how long it takes in this instance. We can see traffic is already getting through. So once this is done, what we can also do is we can go back to the Azure portal. So so it took 37 seconds, this instance. If I minimize this, and do a quick refresh, what we expect to see now is that we would expect the 2.11 routes to be totally removed. Instead, we will now see 2.12 as the path to go out to the internet. So that's the benefit of utilizing Route Server, to be able to go in and do these changes through dynamic routing without needing to use any type of static route. So here you could see the internet path 0/0 is now going through 2.12. So that's what I want to showcase from a demo perspective. So let me come back to my slides. And I'll cover another scenario where customers can utilize Azure Route Server. So a third pattern where customers would be utilizing is if customers have or deployed an SD-WAN appliance or any type of a router as an appliance in the platform. Traditionally, they would, again, have to use user-defined routing to say, if express route fails or if this path is not available, use this path as the next hop. So in this example, what we have is we have express route connected as the primary path. So all of the traffic would go through express route as the primary path. And then what happens here is that if express route is not available, then the traffic would automatically go through the NVA. So here you could see I have an NVA deployed. And then, as I mentioned in my active passives demo, we are using ACE path prepend. So here I've repeated the ACE path to say that this is my longer prefix and the longer path to get back to on-premises. So express route is not available. Now I will switch over to my SD-WAN path and then use that route to get back to on-premises. So in summary, Route Server enables to learn routing information dynamically by utilizing express route gateway, VPN gateway, or it can also integrate with any virtual appliance that supports BGP multipath, and then can inject routes back to the platform. The key thing here is that the Route Server does not participate in the data path, so it's only exchanging the routing. Data path is still direct. The VM will go direct to the NVA, and then if VM is talking back to on-premises, it will go direct to the gateway, and the gateway will be sending traffic back to on-premises. We also looked at 3 use cases. So Deepak covered the first use case where a lot of customers who would want to use branch connectivity. They want to use express route and VPN in combination. Before Route Server, we did not have any mechanism to exchange route information between express route and VPN in a hub-spoke deployment. So using Route Server enables routes to be exchanged between express route and VPN. So that's the first use case we had a look. And then use case number 2 and use case number 3, we are taking advantage of network virtual appliances or SD-WAN appliances, learning those routes dynamically, and then injecting them back to the platform. And these appliances can be configured either as active-active, or they could be configured as active-passive implementations. Before I wrap up the session, I will also cover some of the resources. So all of the demo resources that I've used to demonstrate today is all available on GitHub. A lot of these resources here, so example, this is a example written by one of my colleagues to demonstrate how an NVA can utilize active-active plus work in a forced tunnel mode. And I have additional resources here, how we can using Route Server, leverage Azure as an internet breakout. And then all of the other scripts that I use to demonstrate the active-passive scenario and the active-active scenario is also available in the same GitHub repository. We also have quite a few patterns created already in our quick start repository. So if you go to Route Server documentation, which is available here, you would be able to access some of these quick start, the quick start repository to go in and spin them up within your own Azure environment. We also have a few blog posts, again, written by some of my colleagues. So this is an NVA that is deployed across 2 different regions, and it's then taking advantage of global VNet peering and VXLAN integration to integrate the 2 NVAs. And then this is, again, using Azure Route Server to learn those routes from the NVA and then inject them back to the platform. This is another pattern, as I mentioned before, where you could use Azure as an internet breakout. So this is where you have an appliance on premises, and the appliance is pointing default path out to the internet through the NVA deployed in the Azure VNet. So rather than breaking out from on premises, you can utilize your existing investment if you have firewalls deployed, or if you have secure gateways deployed in the cloud. You can take advantage of those resources that you've already built to break out to the internet. So that's another pattern. So with that, I want to thank you all for joining this session and listening to myself and Deepak about Azure Route Server. So Azure Route Server is still in preview. We expect this service to be generally available in few weeks, few months. And with that, I want to thank everyone and open up for any questions.
Thanks, Nirmal. We'll just give everyone a minute to put their questions in the Q&A section there if there are any. If not, I guess you've answered all questions, which is great. I just wanted to say thank you again to both Deepak and Nirmal for joining us today at the Microsoft Reactor Sydney. And to everyone that joined today, thank you for joining. Remember to please visit that check-in link and add in the event code 14240. You will be able to get all the additional resources for today and the ones that Nirmal just spoke about at the end there. Most of those are in that check-in link there. So you can visit that one and check in. Also, if you have time to do the survey, same event code, and the link is just a bit further below that one. Also, this one will be on our YouTube channel straight after this one. So if there's anything that you missed from today and you'd like to go back and have a look at, you can do so on the our YouTube channel, which we've shared with you in the check-in link. Looks like we've had no questions come through. So thank you very much again to Deepak and Nirmal for joining us at the Reactor Sydney today. And thank you to everyone for tuning in, and we'll see you next time. Thank you both.
Thanks, Sarah.
Thank you.